Welcome and hello. This is a video lesson on the HEC-RAS controller. I'm titling this one Node Types and Index Values. In this lesson, we'll learn about different node types, such as for bridges, culverts, cross-sections, and so on. We'll learn about their index values and where to find those index values within the .g number geometry file and why that is important. So what you see on the screen here is my HEC-RAS. I have a very simple geometry file in the geometric data editor down below. Single river, single reach. I have a bridge right here that's centered at river station 650, and then a lateral structure further downstream that spans river station 480 down to 220 over the left bank. As you probably noticed, there's also a number of cross sections. So every 100 feet, we have a new cross section. We can check out that cross section data, and then we can also check out the data for the bridge and the lateral structure. Okay, we're not going to dig too deep into those details because what I want to introduce is the concept of nodes, node types. Put the table that I'm looking at right now on the screen, but basically this table 3 here, HEC-RAS node types and their edit add subroutines is a good introduction to how we would be adding some of these structures, such as cross sections, culverts, bridges, and so on, to our geometry file using the HEC-RAS controller. As you notice, there's 6 different types, so the index values range from 1 up to 6. 1 is cross section, 2 is culvert, all the way up to 6, which is for lateral structures. The third and far right column in that table is the edit underscore add subroutine. So all of the subroutines start with edit underscore add, and then there's a couple of other letters such as XS for cross section. BC is actually used for bridges, culverts, and multiple openings, and then IW and LW for inline structure or lateral structure. The W means weir, so inline weir or lateral weir. Go ahead and show you where we can find those in Excel. So fire up your Excel, make sure you have the developer toolbar clicked. So you see the ribbon, click on Visual Basic, make sure to go to Tools, References, and include your HEC-RAS for whatever version you're running, and then go up to View Object Browser, select RAS for whichever version that you included as a reference. And then what you see here is a number of procedures are all starting with edit underscore at the very top, edit underscore add BC, and then the last edit related procedure here in the HEC-RAS controller class is edit underscore SS. Now, the 4 procedures that were mentioned in that table are the 4 at the top, which start with edit underscore ADD. So BC, LW, IW, LW, and XX. This is for bridges, culverts, and multiple openings. IW that would have a node of 3, 2, and 4 respectively. And then for inline structure or inline weir, that node type index is 5. For the lateral weir, that node type index is 6. And then for the cross section, node type index is 1. Okay, so let's put that away for now and then go back to our HEC-RAS. So for each of our cross sections that would have a node index 1, and then the bridge right here would have a node type index 3, and then our lateral structure, which is currently highlighted, would have a node type index of 6. So let's check out our geometry file associated with this current geometry. That is up here, geometry base project.g01. Okay, so here's my project directory. G01 is right here. So I'm going to open this up in a text editor. Okay, it opened up on my other screen, but here it is. So this is the very top of the file right here. And what we're looking for is this keyword right here, or I should say this particular term, where it says type space rm space length LCHR equals. You're probably going to see this string a number of times in your .g geometry files. And what this does is it references a node. In HEC-RAS, a node is any feature that occupies a discrete location on a river reach spatially ordered on that reach by the numerical string value, which is the river station. So what we're looking at right here on what is line 14, scroll up a little bit, is the cross section, because this right here, the first value, first integer, the first character you're going to see after the equal sign is going to be that node type index. So because it says it's a 1, we can look at our table. That means the node type is a cross section. And then what we're seeing here for 1000, I believe this is the river station. And then the last 3 values, I believe, is the downstream distance to the next cross section, which is 100 feet in my case. All right. So what I'm really trying to harp on in this particular lesson is this 1 right here represents a cross section. Right? If I scroll down a little bit, it looks like right here is a similar looking string. Yep, that's the same string that I was searching for. And we have another 1. This is associated with cross section at river station 900. The little asterisk right here represents that it was actually created using the interpolation tool. Okay, so similar as what we saw before. I'm not going to go into the details about the cross section itself. This is the station elevation data right here. There's 8 points. There's Manning's and roughness coefficients and some more data. Further down, we have right here, this is the cross section at river station 800. And then the next one, there's 700 right there. Okay, so here is a node type index 3. This is our bridge now, which is centered at river station 650. And now we have some different data associated with that geometry. So for instance, the bridge deck, and then there's 3 piers associated with that bridge. In fact, it may be a little bit more efficient if I just copied that string and then find, and then clicked on find all of this string in the current document. Okay, so here are my search results. It found a match on line 14, 27, 40, 53, 66, and so on. So this is what it was searching for. And we have a 1, 1, 1, 1, 3, 1, 1, 6, 1, 1, 1, 1, 1. So the 3 is for the bridge at river station 650. And then the 6 is associated with the lateral structure, which starts at an upstream river station 480. I can go ahead and just click on that. It'll take me to that particular line. This IDE I use a lot of the time is Notepad++, in case you're interested. But a lot of IDEs have similar search capabilities like what I'm showing here. All right, so just for kicks, let's go ahead and close that. Let's add an inline structure. How about further upstream, maybe at river station 850 right here. We'll save the geometry file and then we'll reopen it to search for node type index associated with that inline structure or inline weir, which is node type index 5. Okay, so it's real quick, inline structure. I'm going to go options, add an inline structure. It's asking me for the river station. I'll say 850. Okay. I don't think I need to add any data at the moment. Let's just say the distance is 50, the width is 20. That's good. Okay. And then close, file, save the geometry. You can see on the plan view here is the inline structure we just added. Of course, we need to add more data if we're actually going to run the simulation, but let's just check that geometry file. So just to be safe, I'm going to refresh. And then here is that project.g01 file. I'll open again with my IDE. All right, here it is. Here is the cross section at river station 1000 because there is the node type ID of 1. And then right here is the cross section at river station 900. And then further down right here, we have a node type ID of 5. That's associated with our newly created inline structure because node type index 5 is for node type inline structure, which has a river station that we set at 850. All right, so that's it for this lesson. We talked about the node type indexes and the different node types and how we can find them by looking at the .g number geometry file and coordinating how some of this text in the geometry file corresponds to the geometric structures in our geometry, which is cross sections, lateral structures, bridges, inline structures, as well as multiple openings and culverts.